Hi everyone, I am Kiranmai. Welcome to my channel Chemistry Tutorials by Kiranmai. In last video, we discussed about black body radiation and photoelectric effect. In these two topics, black body radiation and photoelectric effect, we discussed that the electromagnetic radiations will have particle nature along with its wave nature. So again here we are discussing about this phenomenon atomic spectra, in which it shows that electromagnetic radiations will have particle nature, and along with it we also get an evidence for the quantized electronic energy levels in the atom. If we consider the speed of light, the speed of light depends on the medium through which it passes. See, speed of light depends on medium through which it passes. So when the light is passed through the substance, that means it may be a transparent or opaque one. If the light travels through the substance which are transparent or opaque, then automatically the speed of the light gets decreased due to density of this medium. So speed of light depends on medium through which it passes, and as it decreases its speed, it also gets deviated from its original path. So when a beam of light passes through a certain substance which are transparent or opaque, it gets decreased in its speed. Along with it, it also gets deviated from its original path. This phenomenon is known as refraction, which is the most common property of the light. Along with reflection, light also shows refraction. So when a beam of light gets deviated from its original path, this phenomenon is known as refraction. So when a white light is passed through a prism, when a white light is passed through the prism, then it automatically gets deflected from its original path, and then it also shows the splitting of this white light into different colors. So here the white light, when passed through prism, the light gets bent. As we all know that the visible region of electromagnetic spectrum consists of different electromagnetic radiations of different wavelengths, and they are violet rays, indigo rays, blue rays, green rays, yellow rays, orange and red color rays. When we observe this, we can also note that wave with shorter wavelength deviates more, and wave with longer wavelength deviates less. See here, when red light is considered, its wavelength is around 700 nanometers. Red light 700 nanometers. And when we consider violet light, its wavelength is around 380 nanometers. So here violet light have shorter wavelength than red light. So violet light deviates more. So shorter wavelength deviates more, and the red light which have longer wavelength when compared to violet light deviates less. See here, white ray passes through prism and gets deviated. This is the original path. From this path, red light deviates less, whereas violet light deviates more. When white light passes through the prism, see here, this is the path of the light, and this path of light we can see that red light is getting deviated less from the main path, whereas violet light is deviating more. And then this deviation of white light into different colors also shows the spreading of the series of colored bands. This spreading out of here white light into different series of bands, is called spectrum. This spreading of light into colored bands is called spectrum. So colored bands is called spectrum. And this one here we are getting a continuous spectrum. Here we are using continuous spectrum. Why? Because if we observe the colors coming in the spectrum, colors coming from the prism of the spectrum, we cannot distinguish each color. Here violet is merging into indigo into blue. Blue color is getting merged in with yellow color, green color. Green color is merging with yellow color. Yellow color is merging with orange color. Orange color is merging with red color. So here we cannot find any gap between these colored bands. So this spectrum is called continuous spectrum. And we also using the terms emission spectrum and absorption spectrum while studying the spectra of an atom. Let's know the meaning of emission spectrum and absorption spectrum. When electromagnetic radiations interacts with matter means simply by exposing the substance to electromagnetic radiation causes a change in atoms or molecules energy. So here atoms or molecules present in this matter absorb electromagnetic radiations. Here we discussed that electromagnetic radiations will have a quantized energy packets, and these energy gets absorbed when they interact with matter. So atoms or molecules absorb energy in electromagnetic radiation and then they get excited excited to higher energy state. Higher energy state means they get absorbed energy and then they move into higher energy state, which is highly unstable. Atom or molecule will always tend to be in the state of stable, that is always they tend to get or acquire stable state. So when they move into unstable higher energy state, they will not be in that state for long time. So when they come back to stable state, that is lower energy state, they release absorbed energy in the form of electromagnetic radiation. So here electromagnetic radiations are absorbed by atom or molecule and then they get excited, and which is they move into higher energy state which is unstable. So while coming back to their original lower energy state, that is stable state, they gives off energy in the form of electromagnetic radiations, and these electromagnetic radiations will have different wavelengths. Different wavelengths. When these different wavelengths are passed through the spectrum, when passed through prism, we get a spectrum. This spectrum is called emission spectrum. Emission spectrum. The term emission is used. Why? Because they are emitting electromagnetic radiations, and these emitted electromagnetic radiations are passed through prism and then we are getting spectrum. So this is called emission spectrum. Here we discussed that when light ray passes through prism, we get continuous band, continuous spectrum, continuous colored bands without no spaces between them. But when we compare to continuous spectrum with emission spectrum, there is a difference. See, if it is a continuous band, we will not observe any energy gaps, that is, we cannot get any gaps in this spectrum. But in emission spectrum, we are getting electromagnetic radiations of different wavelengths, but these different wavelengths will not merge with one another. There will be a difference in wavelength with other electromagnetic radiations, which can be noticed in the spectrum as dark spaces. See, these are the colored lines we are getting, and these are the dark spaces. If we observe the spectrum of an atom, that is particularly emission spectrum, we can see lines in the spectrum. So these lines are called, these spectra is also known as line spectra or spectrum. This is also known as atomic spectrum, atomic spectrum. Why this is called atomic spectrum means for every atom, for each and every atom, that is when we take hydrogen atom, that is for every element we'll get a specific atomic spectrum. Okay, so when electromagnetic radiations get interacts with matter, atom or molecules will get excited to higher energy state which is unstable, and then they come back to lower energy state which is a stable one by giving off energy in the form of electromagnetic radiations of different wavelengths. When these electromagnetic radiations are passed through prism, we get a spectrum known as emission spectrum. This emission spectrum is quite different from the continuous spectrum. So, emission spectrum of atoms in gas phase show dark spaces between the lines. This spectrum is also called line spectrum or atomic spectrum. And then what is meant by absorption spectrum? Absorption spectrum. Absorption spectrum. So when electromagnetic radiations are made to interact with matter, that is atoms or molecules, what happens? They absorb electromagnetic radiations. So all electromagnetic radiations will not be absorbed by the matter. They absorb particular radiations and gives off remaining electromagnetic radiations these electromagnetic radiations. So see, the object appears green color when the white light is made to interact with it. If you take leaves and when we incident white light or visible light, the leaf appears green because it absorbs all radiation except green color radiation in visible light, and then it gives off green light, so it appears green. So similarly, the matter will not absorb all electromagnetic radiations, but few radiations are left without absorption. When these electromagnetic radiations passes through the prism, we get a spectrum known as absorption spectrum. Absorption spectrum. These absorption spectrum will also have dark spaces between them. These dark spaces are nothing but the electromagnetic radiations missing from this white light. So these emission spectrum and absorption spectrum will be like photographic negative with each other. The dark lines which are appearing in the emission spectrum appears as colored portion in absorption spectrum. The colored portions which are appearing in electromagnetic radiation appears as dark spaces in absorption spectrum. So absorption spectrum is photographic negative of emission spectrum. Absorption spectrum is photographic negative of an emission spectrum. If you see this picture, see when a substance, a white light, gives out white light. Okay, this here they are saying black body means which absorbs all radiations and it emits all radiations. When this light is passed through prism, we get continuous spectrum. Continuous spectrum means the colors will be merged like we see in rainbow. See, like rainbow, we cannot distinguish between these bands like continuous spectrum. And when the gas in excited state comes back to its normal state, gives off radiation in the form of electromagnetic radiation of different wavelength, and when it is passed through prism, we get emission spectrum. There will be dark spaces in this spectrum. When the radiation is passed through a matter, it absorbs energy, and some of the radiations is not absorbed by this matter. This radiations, when passed through prism, we get spectrum. This spectrum is known as absorption spectrum. Here you can observe that the lines in the emission spectrum, colored lines in the emission spectrum, appears as the dark spaces in absorption spectrum. Similarly, the dark spaces in emission spectrum appears to be colored portion in absorption spectrum. So we are saying that absorption spectrum is photographic negative of an emission spectrum. Hope you observe this difference and you understand what is meant by absorption spectrum and what is meant by emission spectrum. Study of these emission spectrum and absorption spectrum is referred to as spectroscopy. Study of these emission spectrum and absorption spectrum is known as spectroscopy. What is the use of this emission spectrum means every element will have a unique line emission spectrum which is used to study the identification of elements. So each element has unique line emission spectrum. So when we know what is the spectra of particular element, then we can identify the unknown atoms in the given sample. For example, let us consider the sample A, B, C, D. Elements A, B, C, D. And let the line emission spectrum of these elements be like this. Like this. And we observed the sample with the line emission spectrum like this. This is sample which gave the line emission spectrum like this. We already know that these atoms will show line emission spectrum like this. From this information, we can identify the atom which is A or B or C or D in the sample. So if you observe this, we can say that the sample contains the atom B. So like this, the scientist Robert Bunsen who was one of the first investigators to use line emission spectrum to identify elements in their minerals. Generally in minerals we get the elements. So he identified rubidium, cesium, thallium, indium, gallium and scandium. These elements are identified from their minerals by using this line emission spectroscopy. And scientists also discovered the element helium present in sun by using this spectroscopic method. So this is emission and absorption spectrum. And then we are discussing about the line spectrum of hydrogen. So can you guess how the line spectrum of hydrogen is found? Pass a minute. Yes, when hydrogen gas is irradiated with electromagnetic radiations, or if we supply energy by passing electric discharge through hydrogen gas, then this hydrogen atoms absorbs energy and get excited to higher energy level, which is stable or unstable? Yes, unstable. And then they come back to stable lower energy state by giving off energy in the form of electromagnetic radiation of different wavelengths. When these electromagnetic radiations were passed through the prism, we get a spectrum called emission spectrum or atomic spectrum of hydrogen. Here we are using hydrogen. So hydrogen. And when we observe the emission spectrum of hydrogen, it consists of several series of lines. And these series of lines were named after their discoverer, like Lyman series, Balmer series, Paschen series, Brackett series, Fund series, like that. Balmer in the year 1885 observed these spectral lines in the visible region. Spectral lines in visible region. And then these spectral lines which are in visible region are named after the scientist Balmer, known as Balmer series. Balmer series. And when these spectral lines are expressed in terms of wave number, as we discussed earlier, the number of wavelengths present in unit length is known as wave number. See here, if we consider this one as unit length, number of wavelengths means the distance between two successive crusts or two successive troughs is known as one wavelength. So number of wavelengths in unit length is known as wave number. So these spectral lines, when expressed in terms of wave number, then they obey the formula wave number mu bar is equal to 1,09,677 into 1 by 2 square minus 1 by n square centimeter inverse. So here n is equal to 3 or n is greater than 3. So n is equal to greater than or equal to 3. So here the series of lines described by this formula appearing in visible region of the spectrum is known as Balmer series. And then later the Swedish spectroscopist, means the Swedish scientist who was working with the spectroscopy and all, by the name Johannes Rydberg, Johannes Rydberg noted that he observed all the series present in hydrogen spectrum, and then he gave an expression nu bar is equal to 1,09,677 into 1 by n1 square minus 1 by n2 square centimeter inverse. Here n1 is equal to whole numbers 1, 2, 3 and so on, and n2 is equal to n1 plus 1. If we consider n1 as 1, then n2 becomes 1 plus 1, 2. If we consider n1 equal to 2, then n2 becomes 2 plus 1, that equal to 3, and so on. And here the constant 1,09677, that is 1,09,677, is known as Rydberg constant. Rydberg constant. Here we are discussing about hydrogen. So Rydberg constant of hydrogen. So if n1 equal to 1, then the series is Lyman series. Lyman series. It is observed in ultraviolet region. If n1 equal to 2, n1 equal to 2, the series are Balmer series. Balmer series, and it appears in the visible region. If n1 equal to 3, then it is Paschen series. n1 equal to 4, then it is bracket series. n1 equal to 5, then it is fund series. And these three series, Paschen, bracket, fund series, will comes under the infrared region. Infrared region. This is the series of lines observed in the hydrogen spectrum. So see here n1, n equal to 1, n1 equal to 1 means Lyman series. It is observed in ultraviolet region. If n is equal to 2, n1 is equal to 2, then we get Balmer series which is in visible region, and n equal to 3, 4 and 5 are like, they are known as Paschen bracket fund. They appear in infrared region. So this hydrogen spectrum is very simple one. For other elements, this spectrum which we get will be more complicated one. So heavier the atom, the complexity of the line spectrum obtained will be more. So hydrogen will get simple line spectrum, and for heavier atom we get complex line spectrum or complex line emission spectrum. When we observe all these line spectrums, we can say that they are unique. That is, for every element, whether it may be hydrogen or helium or some other substance, some other elements like carbon, nitrogen, like that, every element will have a unique line spectrum like our fingerprints. For every person, the fingerprints will be different. Similarly, for every element, the line emission spectrum will be different. So there will be a uniqueness in line emission spectrum, and there is also a regularity in the line spectrum. Regularity in the line spectrum means, here we can see that in the there will be one order in the spectrum, one regularity. Why these regularity occurs means, within the atom, that is within the atom, there are some quantized energy levels. Quantized energy levels. So that only we will have regularity in the line spectrum. So quantized energy levels. So due to this quantized energy levels, line spectrum shows regularity in it. So this is the basic concept which is taken up by the Bohr to improve the structure of atom. So earlier we discussed that the nucleus will be in the center and the electrons will be revolving round the nucleus. But based on this quantization of energy levels, Bohr proposed the new atomic structure. So this structure of atom, that is Bohr's structure of atom, will be discussed in next video. If you have any doubts, please comment in the comment box. If you understand this video, give me a like and then share it with your friends. Thank you.